Hello and welcome to this pre-recorded training event for International GCSE Mathematics A, KMA0, and the Edexcel Certificate in Mathematics, KMA0. It is based on feedback for the June 2015 Foundation Examination Papers 1F and 2F. To help you get the most out of this session, you might like to have a copy of the Summer 2015 Papers 1F and 2F, and their accompanying mark schemes. You may find the examiner's report useful, as it will be referred to. It would be useful to read the whole of the report at a time convenient to you, as it suggests areas where students may need more coaching, and could give suggestions of things to stress to your students who are sitting future mathematics examinations. The aims and objectives of this event are to provide feedback on performances of foundation candidates in the Summer 2015 examination series, address common issues, consider a selection of questions from papers 1F and 2F where significant numbers of candidates underperformed. Refer to the examiner's reports for papers 1F and 2F. The table shows grade boundaries from June 2011 to June 2015. You can see that for a C grade on the foundation tier this year, a candidate needed 65%. D was 51%, E was 38%, F was 25%, and G was 12%. Small variations in these boundary marks aim to maintain a consistent standard for key grades, and to align with the UK-based GCSE. We are going to look at a few general points that your candidates should always bear in mind when taking IGCSE mathematics examinations. Firstly, a choice of answers gains no marks. If this candidate had given just his or her first choice answer, they would have gained 2 marks out of 3. As it is, they gained 0. This is question 3 from paper 2F, but the issue of choice comes up regularly and must be avoided by candidates. It is essential that candidates clearly show their answers. Writing one number over another, trying to change one number into another, or writing numbers in a very unusual way must be avoided, so that markers are not confused and understand the intention of the candidate. In this case, the correct answer of 4E is not clear. We are now going to look at some individual questions and some of the typical responses that were seen. Firstly, we will look at questions from paper 1F. Starting with number 8, the dual bar chart. You will see from the examiner's report that the early parts of this question were done well, but for part D, it was more common to see an incorrect answer than the correct answer. Our first slide shows a fully correct answer. This candidate has clearly shown their working. The next slide shows some common mistakes. Candidate A found 26% of 65, which was often seen. Candidate B found the fraction of Year 11 students in Class 11A, but unfortunately never showed that they intended to multiply by 100 and gained the wrong answer, so no marks can be awarded. The question is about percentages, not fractions. Candidate C has probably divided 100 by 26, which gives 3.846, but appears to be unsure how to work out the percentage required. To perform well on this question, students needed to be prepared to use a skill other than just reading off the bar chart. Read the question carefully and show careful working. Would you please get out your mark schemes and turn to the scheme for paper 1F, question 10. See if you can see why these two responses got the mark indicated. Please pause the recording now and resume when you are ready. The first response gains a method mark for a correct method to find any angle in the diagram. The candidate has not indicated which angle this is in the working space, but by putting the value correctly in the diagram, the method mark can be awarded. This candidate could have gained the mark for ECB or EBC correctly calculated and identified. Unfortunately, the candidate does not show a correct method to find angle X, or give the correct answer, so no more marks can be awarded. The second candidate has shown a correct method, and correctly calculated 70. But we do not know which angle they intend this to be, so no marks can be awarded. This point has been made in the examiner's report, and candidates should be persuaded to label the diagrams with angles they find to give them the opportunity of gaining method marks. We are now going to look at some typical responses for question 13a. Candidate A has given a correct response and gained full marks. Candidate B gains 2 marks, as the answer is not correct. 1 too many zeros after 1768. This candidate gains a method mark for 52, and then another method mark for the digits 1768. Candidate C gains just 1 method mark for finding 48% of 34 million. They then forgot or didn't realize the need to take their answer from 34 million. Here is a summary of what it was that enabled students to do well on this question. Clearly, students need to be careful that they show their working, read and write values carefully from their calculators, and ensure they are giving the answer that is required. We are now looking at question 14a, which requires the candidate to find the length of time between 7:45 p.m. and 6:15 a.m. the next day. The first response we see is fully correct, with working that can be followed. Note that units need to be given here by the candidate, and here both minutes alone and hours and minutes have been given. Only one is necessary, but both are equivalent answers, so not a choice. The next slide shows responses that were common to see, but which did not gain full marks. As was said in the examiner's report, wrong answers often followed lengthy and muddled working. Response A did some meaningful working, but failed to get any marks by being 1 hour out and giving the answer in an incorrect form. Responses B and C are almost correct. 10 hours 30 minutes and 10:30 are both answers worthy of some credit, and gain 1 mark out of the possible 2 marks. The candidates showed that they could deal with time, but were unable to write the length of time in a correct way. Students who did question 14a well were able to work with time, followed a logical method, and were able to write a length of time correctly with units. Next, we are going to look at question 15, involving a scale given as a ratio. The slide shows a correct response, where the student has changed the units from meters to centimeters, and then divided by 200, giving the correct answer for 3 marks. Many students were unable to interpret the question in any meaningful way, with many blank responses. The next slide shows some typical incorrect responses. It was common to see responses where the student stopped partway through. Candidate A gains a method mark for dividing by 200, but no more marks as the units are incorrect. Response B was similar to ones frequently seen, where, because it was ratio, the candidate thought it must be share the given amount in that ratio. So, summarizing for question 15, candidates did well if they recognized the need to change units, and also understood how to deal with a scale given as a ratio. We are now going to look at question 22, a Pythagoras question. The examiner's report tells us that incorrect approaches and answers were far more common than the right one, which may surprise you. On this slide, we see a fully correct response. Please turn your mark schemes to this question, and have a look at the next slide to see if you can see why the responses were worthy of the mark allocated. Please pause the recording and resume when you have had time to look at these responses. Response A shows squaring and adding rather than subtracting, and this lost all the marks. Response B started well, but although the student showed the method to find the square root of 2.56, they never actually calculated it, giving 2.56 as the answer. This response gained 2 method marks for a fully correct method seen. Response C has an almost correct answer, with a correct method shown. Unfortunately, the candidate prematurely rounded and then gave a slightly inaccurate answer. The 2 method marks can be awarded. Premature rounding should be avoided, especially when there are only 2 decimal places in the working anyway. We are now going to look at some of the questions and responses from paper 2F. Firstly, question 8. A question requiring the use of perimeter to find the length of fence needed to put around a garden. Then subtracting the length of fence that Dan already had, and finding how much he still needs. On this slide, we see a completely correct response. It was quite rare to see such a response. The first response on this slide gained full marks, but it is risky not to show any working, as a small slip would amount to no marks. But with working, method marks can be awarded. The second response shows a typical response, where the candidate incorrectly thinks they need to multiply the measurements, no marks are awarded here. Other typical incorrect responses added only one 8.3 and one 4.5, forgetting the need to add all edges. Students did well on this question if they understood that the question involved the use of perimeter and knew how to find this. We will now look at some responses to question 12, a shopping bill, where many students found the idea of getting change a challenge. The first response we see is fully correct, with careful working shown. The second response shows a fully correct method with an arithmetic error. The candidate got 3.70 rather than 3.75 for the sum of 2.50 and 1.25. But as the method has been shown, credit can be given. This candidate gained 2 method marks, but lost the final accuracy mark. The first response on this slide shows a candidate who completely ignored the £1.30 change and divided by 2 and then 2 again, rather than by 3 to find the cost of a pen. This candidate gained 1 mark for subtracting 2 out of the 3 sums of money from £10 and no more marks. The second response shows a candidate who subtracts all 3 sums from £10, gaining the first method mark, but gives an incorrect answer of £1.25. If the candidate had shown 4.95 divided by 3, they would have been awarded the second method mark. So candidates did well in this question if they understood that change means money not used. Clear working often gained the students' method marks, even when they gave an incorrect answer. We are now going to look at some responses to question 13c. This question needed a full description of a single transformation that mapped triangle P to triangle Q. This first response is fully correct, showing the 3 aspects needed to describe a rotation. Firstly, that it is a rotation. It is a clockwise 90 degrees or anti-clockwise 270 degrees rotation. The point that it is rotated about, which is 0 minus 1 in this case. Note that the phrase rotation at point is acceptable, instead of rotation about the point. This slide shows some typical responses. Firstly, the student who misses the fact that it is a single transformation, and after rotating it, continues to move it in some way. If a candidate gives more than one transformation, they gain no marks. So, 0 for the first response, even though they have mentioned rotated. The second response gains 1 mark for the correct center of rotation. But turned is not a substitute for rotation or rotated. And while 90 degrees is correct, the direction, clockwise in this case, has been omitted. Candidates did well on this question when they used the correct terminology and gave a thorough description of a single transformation. Question 15 was poorly done by the majority of students. Many seemed confused by the terms mean, median, mode, and range. and the question was further complicated by the scores appearing in a frequency table. Would you please get out your mark schemes and mark the 2 pieces of work here? Please pause the recording and resume when you have had time to look at the responses on this slide. Response A. A. Correct, 1 mark. B. Incorrect, 0 marks. The scores range from 6 down to 1, which is 5. C. Incorrect, 0 marks. The student has found the median of the values in the frequency column. D. Incorrect, 0 marks. The candidate has found the mean of the 6 numbers in the frequency column. E. Incorrect. The second response is better. A. Correct, 1 mark. B. Correct, 2 marks. C. Correct, 2 marks. Candidates who wrote the scores out like this, while time-consuming, often gained full marks. D. Incorrect, 0 marks. Very few correct answers were seen for this part, as the students didn't understand how the table gave information about the probability of landing on a 4. We are now going to look at question 18C, which needed the candidate to solve an equation with the instruction to show clear algebraic working. International GCSE papers often ask candidates for clear algebraic working to be shown, and without it, candidates can generally gain no marks. The 2 responses here both give the correct answer, but only the first one shows adequate algebraic working. The first one gains 3 marks, and the second gains no marks. If you look at the mark scheme, you will see that just showing one stage of algebra was sufficient to enable a student to gain full marks. So that showing, for example, 5x plus 8 equals minus 3 is sufficient algebraic working for a method mark. And if followed by the correct answer, then full marks can be awarded. Summarizing, it is essential that if a question includes the clause "show clear algebraic working," that candidates take note of this, if they are to benefit from the marks available. Question 19 was poorly done by students taking this paper. This slide shows a rare but fully correct response with careful working shown. This slide shows just one of the types of mistakes that were seen on this question. Here the candidate seemed to start correctly, only to follow it with working that showed they thought Sarah got $15. Some candidates showed working indicating they thought Emily got $15, and still others just divided $15 by 13, the total of the 3 shares. In summary, candidates did well on this question, if they read the question very carefully and understood that it didn't mean dividing the money in a given ratio, or one person getting the $15. The last question we will look at is question 21 from paper 2F, the trigonometry question. Foundation candidates generally find these questions difficult. If we look at this slide, we see a completely correct solution. It was common for candidates to use tangent to find the opposite side, and then to use Pythagoras to find the hypotenuse, rather than the alternative method of using cosine. Can you see why the second response here gains 2 marks? Please pause the recording and see if you can see why 2 marks are gained. It is because the candidate has shown a fully correct method, but their calculator has been in the wrong mode, and the answer comes from using grads rather than degrees. This slide shows typical responses. In the first, the candidate has found the opposite side instead of the hypotenuse. Had they continued and used this side in Pythagoras, we could have awarded method marks. The second response was typical, when a candidate used cosine as they multiplied 11.3 by cosine 39, rather than dividing 11.3 by cosine 39. Candidates who did this often picked up 1 method mark for a correct first stage. This candidate, however, went straight to an incorrect calculation. This slide summarizes some of the reasons candidates did well overall. And this slide summarizes some of the reasons candidates did not do well overall. This slide gives some information about the statistics available to teachers. This slide gives some information about developments in GCSE and GCE. Thank you.